Hello and welcome to this course. Alright, before we start speaking about neural networks and how they work and how the forward propagation works and how the back propagation works and all of these things related to neural networks, let's first understand the essence behind neural networks. So let's get going. Now let's start very simple. Imagine that you want to predict your output, your desired output called Y, if you'll fail your exam or not, okay? So based on your data set, based on your inputs that you have, you want to predict if you fail your exam or you don't fail your exam. So when you fail your exam, this is represented as a 0, and a 1 is represented when you don't fail your exam. Therefore, your output, your desired output Y, can be either 0 or 1. So again, 0 means that you fail your exam, or 1 means you don't fail your exam. So you're trying to predict Y, which is either 0 or 1. Okay? So this is what we want to predict. This is the output that we want to predict. Now, the inputs, okay, the inputs to the problem that you're trying to solve might include things that do influence the prediction or things that don't influence the prediction. So for example, your inputs might be how much do you study, how smart are you, your previous knowledge on the subject that you're doing the exam on, and your name. Now, for example, this really influences your prediction. Okay, these two do help. Okay, so for example, if you're smart, it does help you get better results in your exam, but it's not really the reason if you get better results. Okay, the main reason is how much did you study. Same thing, your previous knowledge. If you do have previous knowledge, okay, then that helps, of course. But again, it's not fully dependent on your previous knowledge. So these are some of the inputs. For example, your name is not dependent on. The performance of your exam is not dependent on your name. Okay, so this is something that does not influence the prediction. So these are, for example, 4 inputs, and 3 of them do influence the prediction, and 1 doesn't influence the prediction. Okay, so these are, in other words, your inputs or your samples or your data that you have. So based on this data, we want to predict whether this person is going to fail this exam, okay, or going to succeed in this exam. Okay, so either pass or fail. So what we want to do is we want to model an equation that gives you the desired output. But now, as I told you, some of these data are not important. So we don't, for example, the name, we're really not interested in the name because it doesn't depend whether a person fails or passes the exam. Okay, so therefore we need to give importance to some inputs and less importance to others, and maybe no importance at all to the rest. So let's see, for example, EX1. How much did you study? Now, of course, the more you study, okay, the better you perform in your exam. So therefore, we want to give a lot of importance to this X1. Okay, we don't want to get rid of it or only take a partial amount of it. We want to consider all this input. Therefore, we give an importance of 1 or a weight of 1. So we weight this input by 1, meaning that we won't multiply it by 1. We don't get rid of it. Okay, so in order to predict Y, okay, it's going to fully consider X1, your input X1. Let's, for example, see our second input, X2. How smart are you? Now, I told you, if you're smart, then that helps. But it's not the main reason why you pass your exam. The main reason is how much did you study. Now, a person that is smart, okay, but did not study for the exam might end up failing the exam, for example. Okay, so being smart helps you, but it's not the main reason to pass your exam. So therefore, let's give it a weight or an importance of 0.5. Okay, let's go to the third input, your previous knowledge. Again, your previous knowledge is something that helps. For example, if you're studying for a mathematics exam, okay, now the previous knowledge you have in high school, for example, does help you. Of course, does really help you in achieving a good result. But at the end, if you studied well, okay, for the content of this exam and you understood everything, then your previous knowledge in that case is not the real reason why you passed your exam. Okay, so again, it helps. So let's give an importance, for example, 0.2. Okay, so we're going to weight this input as 0.2. Now, finally, your name, of course, you might guess, it's completely unrelated and does not influence your prediction, and therefore we want to give it an importance of 0. Therefore, we want to completely get rid of it. So at the end, what happens is you take your input, okay, your inputs, you multiply it with the importance, or this is what this is called weights, okay, and then you get your prediction Y. So basically what we're doing here is, given these inputs, which is x1, x2, x3, and x4, what value shall we multiply it with so we can get our desired output? Okay, so these values are basically the importance of these inputs. Okay, so given all of these inputs, what are the values that we should multiply them? So what is the value that we should multiply with x1, with x2, with x3, and x4 in order to predict our desired output, which is y? Okay, and I repeat again, these values are the weights or the importance of your inputs. Okay, so basically these are what's called weights of a neural network. Okay, and basically, again, I repeat, weights give importance to the inputs. Okay, so you're weighting your input based on how important it is. Now, how can we model this whole thing? Okay, so we have a neuron. This is the very simple, the simplest thing in neural networks is the neuron, and we'll talk about more on the neuron later on in the next video. But for now, this is just the basics. So you have your inputs. Remember we have 4 inputs, x1, x2, x3, and x4, and we have their weights. So 1, 0.5, 0.2, and 0. And what we do is we multiply our input with this weight. Okay, and this is the first term, and then the second term is the second input times the weight, the third input times the third weight, and the fourth input times the fourth weight, and then we add them all together. So basically the incoming weight to the neuron is a measure to what the neuron cares about. Okay, so for example, here it doesn't really care about the input x4. Therefore, the importance to x4 is 0. Okay, so this is what weights is. It's a measure of what neurons care about. Okay, it gives importance to the inputs. Okay, now there's one more thing, which is the threshold or the activation function. Again, this is very basic about the activation. In the next video, we'll be talking more about activation functions, and also in the last video, there's a separate video just to describe all of the activation functions that are used in neural networks. This is just to understand the essence, okay, of neural networks. So, for example, here we have the thresholds. Now, imagine that our weights multiplied with our inputs, when we add them all together, we get a value of 2.8. Okay, now this value, this output value, might not always be consistent. So our output here is not consistent because each time we might have different inputs. Okay, so therefore we need to model this output. So therefore, for example, one of the activation functions is the threshold. This is the simplest one. So we say that if this output is bigger than 1, bigger than or equal to 1, maybe you can say, then output this as 1, and if it's smaller than 1, then output this as 0. So in this case, 2.8 is larger than 1, therefore the output becomes 1. And remember, 1 means pass. That means this person will pass the exam, because we're predicting. So remember, 1 means will pass the exam, and a 0 means doesn't pass the exam. So therefore, if the output here of the neuron is larger than 1, that means the prediction is passing the exam, and if the output here is smaller than 1, that means the prediction is 0, which is not passing the exam. Okay, so that's it for this video. In the next video, we'll start our journey with neural networks. Thank you very much, and I'll see you next time.